right, perpendicular lines make right angles. Lines, rays, or segments that intersect at right angles are perpendicular. The symbol for perpendicular is that upside down capital letter T. Is this a definition, a theorem, or a postulate for perpendicular? Is it a definition, a theorem, or a postulate? Bridget? It's a definition. So in proofs, what are we allowed to write since it's a definition as a reason if we're using this? Def of perpendicular. Since it's a definition, we are allowed to say def of perpendicular. All right. And how do we show right angles in diagrams? We have that little box. So right now, let's look at our number 1. Do we agree that line A and line B are intersecting and making right angles? If they're intersecting and making right angles, what does that mean? What can we conclude about the two lines? James? They are perpendicular. Hey, I have one right angle here, but it is implied if I have one right angle that there's actually 3 more right angles. And I'm not assuming that I know that for a fact. How do I know that there's actually 3 more right angles there? Can someone tell me? All right, let's start with this one. How do we know that this angle 1 is a right angle? Adam? Because we subtract from right 180, right? Isn't that a straight angle? So if one angle on that straight angle is 90, doesn't the other side of it also have to be 90? It's also the same thing here, angle 2. If this is, we're looking now straight angle B, right? With the line B. If that top angle is a right angle, the bottom one has to. And then obviously the same reason for that third one from the other angles 1 and 2. The way we would write this is we would just write A, the perpendicular symbol B. And this reads line A is perpendicular to line B. Right. In number 2, my little angle didn't get transferred, but there should be a right angle by E. There should be a right angle by E. Since there has to be a right angle, since there is a right angle by E, what conclusion can we come to based on our diagram and given information? Mariana? Well, E is 90 degrees, you're right. What else can we conclude? Using perpendicular. Using perpendicular. I see you, Bridget and Adam. Connor. Point D and point F are congruent? Points, no, we can't say points are congruent. What were you thinking? Is that what you were thinking, that the points were congruent?
They just tried to make something out of nothing because there's no other angles really well.
I see. Well, I appreciate you trying versus nothing. What else? What else can we say? Just using our new definition. Noah?
Segment DE is perpendicular to segment EF.
Good. Segment DE, right here. Isn't this segment and this segment where they cross making right angles? So we can conclude based on our given information that segment DE is perpendicular to segment EF. All right, what conclusion, looking at number 3, what conclusion can we come to? Mariana? Good, we could say segment JM, but be careful, JH is a? GH, sorry, GH is what?
A line.
Not a line, 1 point and then 1 arrow. All right, so segment JM is perpendicular to ray GH. Could we have also said that ray GH is perpendicular to segment JM? Would that have been okay? Absolutely. So we could have said ray GH is perpendicular to segment JM. That would have also worked. And also for number 2, we could have said segment EF is perpendicular to segment DE. In number 1, we could have said line, sorry, not A. We could have said line B is perpendicular to line A. Are we allowed to assume perpendicularity in proofs? No, just because it looks like two lines are perpendicular, we cannot assume that they are perpendicular. So let's go through this given information. We'll make conclusions and mark up our diagram. So in our proofs, the first thing we always write is our given information. So I'm going to go ahead and write that out. Okay, so now we go through our given information. We come to conclusions. We make our diagram. So when it says segment AB is perpendicular to segment BC, we need to make a conclusion. So they're saying segment AB is perpendicular to segment BC. Where those two segments intersect, where those two segments touch, we can say we have a right angle. So where is my right angle? Olivia? I'm sorry? B, excellent, at B. So what I'm going to do is I'm going to mark that with a little box. Now, anywhere in my proof, have we written down that angle B is a right angle? No. Do we have to write that? Yes, we have to write that. So statement 2, I'm going to say angle B equals right angle. And what is our reason for that? What led us to that conclusion? What led us to that conclusion, Adam? Def of perpendicular. So what you guys are allowed to write is def of, and then you can draw that symbol for perpendicular. That information from the given is what led us to believe we have right angles. Okay, so here we have DC is perpendicular to BC. DC, segment DC is perpendicular to segment BC. So what do? You go to the diagram. We know where DC and BC will intersect, will create a right angle. So this time, which angle's a right angle? Sophie? Angle C. Now, is that going to be the same reason as step number 2? Yeah, so can I put them in the same step if I wanted to? Yeah, you can. If it's the same reason, you can put it in the same step. If it's the same reason, we can put it in the same step. So I'm going to say angle D, oh, not angle D, sorry, angle C equals right angle. And it was also the definition of perpendicular that led us to believe that, or that led us to that conclusion. Okay, so we went through our given, we made conclusions. Now let's see what we want to prove. We want to say angle B is congruent to angle C. Your first step in every proof is your given. Your last step is always what you want to prove. Now, what have we written so far? We've written angle B is a right angle C is a right angle. I can now say that angle B is congruent to angle C. But this is not def of congruent. I saw a lot of that on the quiz. Or on the test. This is not def of congruent. By definition of congruent is two angles that have the same measurement. In our proof, did we show any measurements? In our proof, we did not show any measurements, so we cannot say def of congruent. This is a theorem. What was the theorem that talked about right angles? I know this. Give me 1 second. Emily.
If two angles are right angles, they're congruent.
Excellent. If two angles are right angles, then they are congruent. All right, let's keep going. When it says find, is that a proof? No, when it says find, that's like an algebra problem, all right? When it says prove or conclusion, that's a proof. But when it says find, that's an algebra problem. So let's go through our given information and mark up our diagram. It's saying ray KJ is perpendicular to ray KM. Can somebody who hasn't participated today tell me what can we conclude if ray KJ is perpendicular to ray KM? I know Natalie's next to you. What is it? Maya? Okay. Good. Can we call it angle K though? Could you, 3 letters? Excellent. Angle JKM is a right angle. And Maya told us we cannot call it with just 1 letter because there's more than 1 angle K. So we can't just call it angle K. So now let's keep going. Angle JKO is 4 times as large as angle MKO. I'm going to choose the smaller angle here. When it says JKO is 4 times as large as angle MKO, which one has to be smaller? Vin? Not Vin. I always call you Vin. I don't know why. You look like a Vin to me. Angle MKO is smaller, but what's your name? Colin? Connor and Colin. Okay, Colin. So whichever one is smaller, we're going to call X. So I'm going to go to angle MKO and call it X. Now, if MKO is X, how would I represent 4 times that? Jocelyn? 4X. So now we've labeled everything from our given information. Can someone think of an equation to help us solve this? Connor.
5x equals 90.
Excellent. X plus 4x equals the whole angle, which is 90. So here we have 5x is equal to 90, and x will equal 18. Now, which angle were we asked to find? Good. So angle JKO, isn't that represented by 4x? So angle JKO is going to be 4 times 18, which is 72 degrees. All right, next one. Given angle 1 is 3 times the measure of angle 2. One step at a time. Which one is smaller? Angle 1 is 3 times measure of angle 2. Sophie. Angle 2. So which one should we call X, Caleb? 2. So I'm going to go ahead. I'm going to call angle 2X. And now angle 1 is 3 times angle 2. So what is angle 1 going to be? Olivia. 3x. But now it's going a step further. Now it's saying angle 3 is 5 more than angle 2. Well, angle 2 is still x. How am I going to represent 5 more than angle 2? Erin. You got it, x plus 5. Are there any perpendicular lines here where we told right angles are perpendicular or any of that? No, we were not told anything about right angles or perpendicular lines. What is the only thing we're ever allowed to assume? Adam. Straight angles. Do we see a straight angle here? Yeah, we know this whole angle is 180 degrees. So what does that mean for angle 1 plus angle 2 plus angle 3? So it equals 180. Angle 1 plus angle 2 plus angle 3, they all have that same vertex, right? They all have that same point in the middle. So now we're going to say 3x plus x plus 5 equals 180. So we have 5x plus 5 equals 180. we have 5x equals 175. So x will equal 35. And now we want to find all three angles. So we know angle 2 will be 35 degrees. Angle 3 will be 3 times 35, which is 105. And angle 3 will be 35 plus 5, which is 40. All right, that's the end of 2.1. Let's talk about 2.2. All right, some new vocabulary, some more definitions. What's really nice about definitions? In proofs, we are allowed to say def of, right? That's really nice about definitions. We're allowed to say def of. We don't have to memorize their exact definition. So two angles whose sum, complementary angles, are two angles whose sum is 90 degrees, which is a right angle. Each of the two angles is called the complement of the other. So here, let's say I have angle A is 50 degrees and angle B is 40 degrees. Those were a little bit too close. I'm fixing my diagrams. Okay, complementary angles are two angles that add to be 90. Will 50 plus 40 add to be 90? Yes. So the way we would write this is we would be able to say angle A comp angle B. What that reads is angle A is a complement to angle B. Angle A is a complement to angle B. You can also say the other way, angle B comp angle A. Angle B is a complement to angle A. All that means is the two angles add up to 90 together. Sometimes we won't be giving measurements. So sometimes it will look like this. So I can tell you right now, based on my diagram, I know for a fact angle 1 and angle 2 are complements to each other, or they are complementary angles. How do I know that angle 1 and angle 2 are complementary angles? I'm not assuming this. I know it. Adam? Because they're adding to make that right angle. So they don't actually have to give you numbers. Like it doesn't have to be 30 and 60 or 40 and 50. Right? You can have the right angle and it's split into two. So this would be angle 1 comp to angle 2, or we can say angle 2 comp to angle 1. So complementary angles add up to 90. Does anybody remember what do supplementary angles add to be? Jocelyn? 180, you got it. So two angles whose sum is 180 degrees, which is also a straight angle. Each of the two angles is the supplement of the other. Do you think we can conclude that angle M and angle T are supplementary angles? Yes. How would I shortcut that? Angle M, sup, angle T. or we can say angle T sup angle M. And that reads angle M is a supplement to angle T, or angle T is a supplement to angle M. All right, also, we don't have to be given any numbers. Right now, can I conclude that angle 3 and angle 4 are supplements? Yes, we are allowed to assume straight angles, so we can say angle QRS is a straight angle, and angle 3 plus angle 4 add to make that straight angle. So their sum creates that straight angle. So I can say angle 3 sup angle 4, or we can say angle 4 sup angle 3. All right, let's do some problems. Are we ready? Word problems. We're going to practice with word problems today, and we're going to practice more with word problems next class. All right, two supplementary angles are in the ratio of 11 to 7. Find the measure of each angle. So this is what I want you to do with the word problems, and it will always work for you if you do this. All right, if it says supplementary in the problem, draw a straight angle. If it says complementary in the problem, draw a right angle. So supplementary, what are we drawing? Straight angle. Complementary, what are we drawing? Right angle. So two supplementary angles are in a ratio of 11 to 7. Find the measure of each angle. Am I drawing a straight angle or a right angle here? Straight angle. So let's draw that straight angle. And then it said two supplementary angles. So I'm going to split this angle into how many angles? The straight angle into? Two, because it says two supplementary angles. So there's my two angles. Now, some people had difficulty with this. All right, when it says the ratio of 11 to 7, I can't write 11 and 7. I cannot write just 11 and 7. I lost it. Give me a second. Matt. Chase, I'm so sorry.
You do one angle at 11x.
Good. One angle at 11x and the other angle at 7x. The minute you take numbers out of a ratio, you have to put a variable with it. You have to put an x or a y or a w, whatever you want, but it has to be a variable. Based on this diagram now, can I create an equation? Yeah, what's the equation? Mariana?
11x plus 7x.
Good. 11x plus 7x equals that whole straight angle, which is 180. So now we have 18x equals 180, so x will equal 10. It says find the measure of each angle. So the 11x will be 110 degrees, and the 7x will be 70 degrees. All right, number 2, it says the measure of one of two complementary angles is 3 greater than twice the measure of the other. Find the measure of each. All right, did it say supplementary or complementary? So am I drawing a straight angle or a right angle? A right angle. So I'm going to go ahead, I'm going to draw my right angle. And now how many angles am I splitting this into? It says the measure of one of two complementary angles. So one of two, which means total of 2. So I need to split this right angle into 2 angles. If at any point I lose anybody, please just tell me to stop. I'm happy to go back and re-explain. All right, now what we're going to do is pick one of these angles and call it x. Doesn't matter which angle you call x. So I'm going to go to the bottom angle, I'm going to call it x. And now the other angle is going to be based on the words. So it says 3 greater than twice the other. So how am I going to represent 3 greater than twice x? James? Good. 2x plus 3. You got it. So one angle will always be x. The other one's going to be based on the words. Can somebody think of an equation to solve this? Chase?
2x plus 3 plus x equals 90.
Good. 2x plus 3 plus x equals 90. Combine your like terms. So we're 3x plus 3 equals 90. 3x equals 87. So x will equal 29. Is that right? Yeah. Find the measure of each angle. Well, the first angle is just x, so that's 29 degrees. So what is the second angle going to be? You got it, 61 degrees. Is 61 plus 29 90? Yeah, should it be 90? If it didn't add to 90, what would that tell you? You did something wrong, right? You did something wrong. All right, number 3. The measure of the supplement of an angle is 60 less than 3 times the measure of the complement of an angle. Find the measure of the complement. So what curveball did I throw in on this problem? Because in the past I said if it's a supplement, draw a straight angle. If it's a complement, draw a right angle. But now I've thrown in some kind of curveball at you. James? I can't hear you. I still can't hear you. Good. I put both supplement and complement. I put both supplement and complement in the same word problem. So anytime it says supplement and complement in the same word problem, we're actually not drawing a diagram at all. It's going to be a very specific let statement that we're going to have to write out. And I'm going to tell you all about that let statement, but I'm going to have us sort of come to the conclusion on our own. You don't have to write this down. Sort of guiding you here to figure something out. All right, let's say I had an angle that was 30 degrees. What is the complement of the angle? So what's the complement of 30 degrees? Chase. 60 degrees. What did you do, Chase, to get the 60?
Since complementary is a right angle, I did 90 minus 30.
You got it. You did 90 minus 30. All right, what is the supplement of a 30-degree angle? Adam. 150. What did you do to get that?
I subtracted 180.
You did 180 minus 30, right? Okay, what if the angle, now let's say the angle is 10 degrees. Say the angle's 10 degrees. What's the complement of the 10-degree angle? Connor? 80. What'd you do? 90 minus 10. All right, what about the supplement of that 10-degree angle? Noah? 170. What'd you do? 180 minus 10. All right, let's go ahead and now say the angle is x. What would be the complement of that angle? Jocelyn? Excellent. 90 minus x. We don't know what x is. That's unknown, right? We use a variable to represent an unknown measurement. So we're saying, well, the complement would be whatever 90 is minus that unknown angle. Well, what about the supplement of that angle? What would that be? Mariana? 180 minus x. Okay, so this brings us back to that horrible word problem with complement and supplement both in it. Anytime you have complement and supplement in the same word problem, I want you to write out this let statement. Are you ready for it? This is what you will write out every time. Let angle equal x. So the angle is the unknown. The supplement will be 180 minus x. And the complement will be 90 minus x. this is what you need to memorize. All right, now you're going to go through and translate the words into symbols. So it says the measure of the supplement of an angle. The measure of the supplement of the angle. Go to your let statement. What did we say the supplement of the angle was represented by? 180 minus x. So that's what we're going to write down. That's not showing up very well. Then it says is. What does is mean? What symbol, Jocelyn? Equals. Is means equals. So is means equals. Then it says, then it says 60 less than 3 times. So let me highlight this. 60 less than 3 times the measure of the complement. Well, do we agree that 60 less than is a minus 60 after the fact? So it's not going to be 60 minus, it's a minus 60. Less than's a flip-flop word. All right, so it says 60 less than the measure of the complement of the angle. Well, what did we say the complement of the angle was? 90 minus x. So it's going to be 90 minus x minus 60. Oh, sorry, 60 less than 3 times the complement. What did I not do? Connor?
You have to put 3 in front of the x.
Not just in front of the x, it's 3 times the whole complement. So what's the whole complement, Connor?
90 minus x minus 60, so.
Nope, the whole complement is just,
Oh, 90 minus x.
so I have to do parentheses around the 90 minus x and then multiply that by 3 in the front. Just the 90 minus x, because that's what the complement is. Now that we have our equation, now we solve for x. So we're going to go ahead. We have 180 minus x. I'm going to distribute in that 3. Don't forget to distribute the 3 to the x. So that's going to be 270 minus 3x minus 60. So now we have 180 minus x is equal to, combine your like terms, 270 minus 60 is 210 minus 3x. I'm going to add the 3x over. So we're going to have 180 plus 2x equals 210. Subtract that 180. So we're going to have 2x is equal to 30. Thank you. So x is equal to 15. Catch up and then we're going to discuss. We're not done yet. Okay, what does x represent according to our let statement? Maya? The angle. X is the angle. So it said, if it said find the angle, that would be easy. Our angle is 15 degrees. But I didn't ask you to find the angle. I said find the measure of the complement. Well, according to our let statement, isn't the complement 90 minus x? So how am I going to find the complement? So 90 minus 15. So our complement is going to be 75 degrees. All right, ready to do a proof? Can I erase some of my work from up top? Anybody still copying that? I can erase, okay. Erase some of this. Okay, so here we have segment T, oh, sorry, let's go write out our given statements, reasons. Right, segment TV is perpendicular to segment VK. We got to go through our given, make conclusions, and mark our diagram. What conclusion can I make if segment TV is perpendicular to segment VK? Emily?
Angle TVK is a right angle.
Excellent, excellent, excellent. Angle TVK is a right angle. I'm marking my diagram. Do I need to write that down in my proof? Yes, because it didn't say TVK is a right angle. So we just marked that, so now we have to write it. So we're going to say angle TVK equals right angle. Who thinks they know the reason for this? Bridget? Excellent. It's def of perpendicular. So you can use the symbol if you want. Def of, and then that upside down capital letter T. All right, so we went through our given, we came to a conclusion. Now let's look at what we want to prove. We want to prove angle 1 is a complement to angle 2. Well, by definition of complement, isn't it two angles that add to a right angle? So can I say that I have a complement now? Absolutely. So step number 3, I'm going to say angle 1 comp to angle 2. And our reason is going to be, who thinks they know? Chase?
Def of complement.
Good. You just write def of comp. Def of comp. C-O-M-P. All right, last one. I'm not writing out my given just to speed up time, but you know on a test you would have to. So the given is just diagram as shown. That's not helpful to us. I need to prove that angle 1 is a supplement to angle 2. Is angle 1 a supplement to angle 2? Based on this diagram? Yes. How do you know? Adam?
It's a straight angle.
Which angle?
ABC.
Excellent. Angle ABC is a straight angle. Excellent. Angle ABC is a straight angle. But has it been told to us in the proof that angle ABC is a straight angle? No. So do I have to write that down? Yeah. So we're going to go through and say angle ABC equals straight angle. Who remembers our reason for this? Who remembers the reason? Erin? Good. You could write AFD, assumed from diagram. Somebody put APD on the test and I had to take a point off. I felt so bad. All right, it's AFD, or you can just write assumed, right? Either one is acceptable. You could write assumed or you could write AFD. Noah? Yeah, I would take assume. Yeah, that's fine. Yeah.
Is assumption?
I think I gave credit for that. I'm not sure. All right, so here we have angle ABC is a straight angle. Now can I say angle 1's a supplement to angle 2? Yes, so statement 3 is angle 1 sup, angle 2, I shortcut it. And our reason is what reason here? Adam? Def of sup, you got it. Oh, let's just do number 6 real quick. It's a really quick problem. Angle 1 is complementary to angle 3. So what does that mean for angle 1 and angle 3? they make 90-degree or a right angle. So angle 1 and angle 3 make that right angle. So here's angle 1, here's angle 3. If the measure of angle 3 is y degrees, so here's y, how large is angle 1? It's not going to be an actual number. How would I represent angle 1 if angle 3 is y? Maya? 90 minus y. You got it. All right, we are done here. Your homework, in case it takes me a minute to post it, this is your homework, section 2.1 and section 2.2, problems from both. I might alter it a little, like I might take off one or two of these problems, but that is the general gist of your homework.